Good afternoon, all. Animation presentation, branch CSE, Division B, subject digital electronics, name, Hazaber Rahman, Ajit Gimire, Sanjit Kumar Das, Eddie Masoda. Today we are here for presenting our animated video on topic, logic gate, gate implementation, Boolean expression. Any idea about logic gate?
No. I have an idea, Goose. It's a gate like this.
You fool, it's not this gate. They are the basic building block of digital system. Let's see in detail about logic gates. They are the basic building blocks of any digital system. It is an electronic circuit having one or more than one input and only one output. The relationship between the input and the output is based on a certain logic. Basically, there are 7 logic gates. Basic gate, AND, OR, NOT. Universal gate, NAND, NOR. Special gate, XOR, XNOR. For your kind information, logic level are represented by mean of voltage level. That is high voltage, 1, low voltage, 0. A question may rise, why these gates are classified as basic, universal and special? Because with the help of basic gate we can form other more basic circuits. Similarly, universal gates performs all the logic operations of other logic gates. And special gates are just the special case of NOR gate. Before moving forward, let's learn about some terminologies. Boolean algebra, it take value either 0 for false, or 1 for true. Note in a circuit are representative Boolean values like A, B, X, Y, Z, etc. Truth table, it is a table used to represent Boolean expression of logic gate function. Each possible input combination to gate depends upon the combination of these inputs. 2 input logic circuits equals 2 power 2 possible combinations. For 2 input circuit, first input is 0, 0, similarly second is 0, 1, third is 1, 0 and fourth is 1, 1. Like this, an input logic circuits equals 2 power m possible combinations. Let's learn about gates symbol and their truth tables. 1. And gate, simply we perform multiplication or dot operation between 2 or more inputs and produce only one output. Output is high only when both the inputs are high, that is 1. 2. OR gate, simply we perform addition or plus operation between 2 or more inputs and produce one output. Output is high only when either one or both the inputs are high. 3. NOT gate, this gate is used to produce complement of input. It takes one input and produce one output. 4. NAND gate, we perform complement of in gate. To make gate negative we simply add bubble at end of gate. Output is true only when either one or both the inputs are false. 5. NOR gate, we perform complement of OR gate and output is true only when both the inputs are false. Six. XOR gate, it has a graphic symbol similar to the OR gate except for the additional curved line on the input side. Output is true only when one of the input is true and next is false. 7. XNOR gate, we perform complement of XOR gate and output is true only when both the inputs are either true or false. Now we are going to see the verification of logic gates and their truth table with the help of logically simulation video. Basically, logic gates are used in microprocessors, microcontrollers, embedded system application in electronic and electrical project circuits, a push-button lock, light-activated burglar alarm, safety thermostat, and automatic watering system, etc. Some advantages of logic gates include, they are quick yet use low energy, they don't get overworked, they can lessen the PRESCRABED and UMBER of input-output ports needed by a microcontroller, they can bring about straightforward data encryption and decryption. Let's learn how can we implement any given Boolean algebra using logic gates. You must be clear that, by using, or appropriately combining logic gates, we can implement any Boolean algebra easily and efficiently. We have just used the term Boolean algebra, we have seen some about it at the beginning, now let's learn in details including its laws and evaluating way. We use a particular order of evaluation way for evaluating. First, priority is given to parenthesis, second to not, third to an, and last or. Before evaluating Boolean algebra, first be familiar with its laws. There are 10 laws of Boolean algebra and they are listed serially with their functions by sides, see them carefully. After being well known of these laws, we are able for evaluating any type of Boolean algebras. Have a look in this problem also which laws are used for implemented as given by side. Now let's learn how Boolean expression of universal gate or implementation, 4 NOR gate steps to be performed for implementing are mentioned step by step. Watch that carefully. Step 1. Common implementation. Step 2. Adding bubbles at end of OR gate at beginning of AND gate. Step 3. Adding NOT gate where there are bubbles. Step 4. Removing even NOT gates. Step 5. Replacing all gates by NOR gates. And at last we get answer which is same as that question. Not only NOR gate but also we can implement NAND gate, only there's one change in step 2, that is add bubble at end of AND gate and beginning of OR gate. Remaining all steps are same as of OR implementation. Now, it's time to see how logic gates are applicable for development of its applications. We will see about construction of microprocessor using logic gates. The fundamental building blocks of any microprocessor are gates, and gates are collection of transistors that electrically mimic a particular logic function, XOR obtain output 1 if both the input are different. NOR gate will output 1 if both the input are 0. Combination of these gates are used to implement everything in microprocessor including functional units like adders, multipliers, etc. In given logical circuit of microprocessor, we have a 1-bit carry adder implementing using logic gates. It will add any two 1-bit numbers and produce a result. As we said, gates can be formed by combination of resistors, diodes and transistors. Let's look how they formed by using these components. Let's see how fire alarm system is constructed using logic gates. As you have seen, components required to construct circuit diagram, uneven component connections formate with each other. Now let's see how it works with the help of truth table which we have provided for it. At first input, 1, that is both smoke sensor and fire sensor are activated, are both gates produces output, 1 that is both extinguisher and alarm will be activated. At second input, 0, that is smoke detected but not heat, only alarm will activate as OR gate produce output 1. At third input, 1, that is heat detected but not smoke, only alarm will activate as OR gate produce output 1. At last input, 0, that is both smoke and heat not detecting, both outputs are also 0, that is no system will activate it. Note, we can use these logic gates for implementing various circuits, which we use in our daily life as well as in other sectors. We wish you have got very much knowledge about gates, gates implementations, Boolean expressions, applicability of its applications in various sectors. We kindly thank you for watching our presentation completely. Thank you so much. Have a nice day.